webinar. We'll give it a couple minutes for the rest of the attendees to join.
Yeah, we still have about a minute. So we'll give it another minute or so.
Perfect.
All right. Thank you all for joining today. This Corning is going to go through their new cell counter that they have, the automated cell counter. So thank you for joining. This is going to be a really great presentation. I'm going to let you know. I'm excited to see it. So we're going to give it another couple minutes before we start, just to make sure we can have everybody on here. And then Alex will take it away in about 2 minutes. So I would like to introduce the presenters from Corning here today. So we have Alex Toomey. He's Corning's product line manager for the life science imagers and molecular biology equipment, to include this awesome cell counter that they have. He's worked with the cell counter from launch year, where he supported the unit as a member of their scientific support team. So Alex will be presenting, and then we have Jeff Partridge, who is their senior scientist in product development with over 20 years of service with Corning. He is the cell counter technical SME and has been involved with the cell counter since the start of the project at Corning. And Jeff will be going through a brief demo for us towards the end of the presentation. So with that, Alex, please take it away.
Thank you, Rebecca, and thank you everyone for joining. I know during these times it's tough to get everyone's time, so we do appreciate it. And another thank you to the Thomas team for putting this together with everything behind the scenes, and everyone did a great job putting this together. So we'll go into it. We'll cover the agenda here. So we'll tell you guys a little bit about ourselves, maybe something different than Rebecca has already not stated. So after that, we'll go right into the cell counter, and we'll define the market niche to make sure everyone's in the right spot. We're going to go over the benefits of automated counting compared to manual counting. I'll give you a brief history of our unit, the cell counter. I do have it here with me today. It does fit in the palm of your hand. Let me see if I can get that camera there. Yeah. So then I'll go into the power of the cloud, because it is a cloud-based cell counter. And then I will go into the unit requirements. There's 4 basic requirements to use this unit. And then I'll go right into the software portion of it, how to count using the Corning cell counter, and then we'll introduce the cloud to you. After that, we'll pass it over to Jeff for a live count at the lab there in Bedford, and then we'll close it up with some questions and specifications. So I'll try to go through this quick. Again, if you do have questions, please type them into the chat, and the moderator will collect those and we'll go over them and try to hit every question there for you. All right, so as Rebecca mentioned, I'm the product line manager for the Corning cell counter in our imaging portfolio. Also the product line manager for the molecular biology equipment. I have handled this machine since I was with the scientific support team since launch year 2018. So this unit has been on the market, coming up on 2 years now. All right. Jeff, you still there? You want to say a little bit about yourself, or are we good?
No, I'm fine. I mean, I'm a senior scientist here with Corning for over 20 years, and I was on the team where this came out of. Again, it's a co-branded device, but I was on the Corning team that helped develop this.
Thank you, Jeff. All right, and I'll pass it back to Jeff later on in the presentation where he's going to take us through a live count with live cells over there in Bedford. All right, so let's define the market niche here. And what we're doing is we're really helping the manual counters move to an automated fashion. What this does is it really quickens the time for your counts. So what we're counting are mammalian cells with this unit. Again, so we're not counting yeast, bacteria, fungi, plant or algae cultures, because the cells there, they grow a little bit differently. They kind of cluster in clumps, and our algorithm is optimized to count those mammalian cells there. So to use the unit, you do have to have a cell size range of 4 to 70 micron. And, to get a little more specific, we're targeting tissue culture applications here. And the big data that this unit produces would be the live count versus the dead count percentages and the total count of your culture there. And, here we are in 2020. A lot of us are returning to the labs. So, when we are returning to the labs at a most likely decreased occupancy rate, I know a lot of the labs around the Boston area are returning into like the 25% range. And then the phased approach that we're taking in Massachusetts, more and more colleagues will get back to work. But this unit is going to save you some crucial time. So the manual counts usually takes from 5 to 8 minutes. And whereas our cell counter, we'll get a good, solid, accurate count in about 10 seconds for you. So here's the customer-facing problem. Up in the top right corner here is a regular Neubauer counting grid. So traditionally, you're going to place your cells onto this slide here, and the cells are going to disperse throughout the whole square. And the way we count today is we average the 4 squares here, and we'll zoom in on 1. And, it's fair to say that everyone's eyes are different in the lab. So really, there's a little bit of a discrepancy when you're counting manually, because you will have cells on the edge. And, where I think this cell is in the square, some people may think it's out of the square. Also, you have to kind of really dial in on these colors here, because the blue cells here are the dead cells, whereas the white cells here are the live cells. So you have to kind of count each square twice, looking for those different cells there. And we have a nice chart here just showing the cost efficiency of the unit. Basically, this says once you get over 2,000 counts, your cost will balance out when you get a automated unit versus the manual counting method. Our cell counter does come with this reusable glass chamber. So that knocks out the consumable cost there when you're using the disposable slides. Also, when you add up the time that it takes to count, you're really saving that time. So basically, you got to think about the cost of the overhead cost there of using the unit. All right. So we will go on to the benefits and reproducibility of cloud-based cell counting. And really, we got 3 main things where it's really fast. It's going to be accurate every time with the right focus level. We operate at low cost, and we continuously add upgrades at no charge. So the reason it's fast is because it is imaged online, so it processes up in the cloud. We'll get into that a little bit later in the presentation here. And what we have here is that it is really, really accurate. So we have a library of around 355,000 features to detect a cell as a cell. So it's a trained, complex algorithm, but really, it's a really simple unit. So it's a simple unit with complex features. And again, the upgrades at no charge. So what we're doing is we're constantly contacting the field and getting their feedback. So really, the voice of the customer has added to this device over the years here. And the reproducibility of this unit really is focus level dependent. So the proper focusing techniques will get you the best and optimal results. So here we have a figure of, what cells should look like, what they shouldn't look like. So here, we really want to focus this unit. And in order to focus it, we just turn this knob either clockwise or counterclockwise, and you'll see the screen adjust there. So we're going to want to get that bright white center with the dark edges for the live cells. And for the dead cells, we are going to want to get dark cells depicted there. So, don't focus too much on the what not to look for. But if you see any halos, we do need to adjust the focus level to look more like this picture here. And then if you see any blurry images on your counting frame, definitely revert and adjust the focus level to what the algorithm is trained for. And there is a little bit of a learning curve to this focusing. It's like any new technology you get. There's going to be a little bit of a learning curve, and a lot of our customers do find it easy to get past that learning curve there. All right, we will go on. So we're going into a brief history and power of the cloud. But before we get to that, I just wanted to show you guys what the unit is. And I do have it here with me, but I think it's easier to show you via, this diagram. So we do have a light arc on it, which throws down a LED light onto the optical window. The adapter plate is here, located as B, and it does look like this. It is a little tough to see on that picture there because it's flat. So that adapter plate is used to keep that chamber in place. However, you do not need to use the adapter plate, which gives us the enhanced ability to move the slide around, which gives us the multi-count feature. And we'll get into that during the live count. So C is the USB cord. This is what you're going to plug into the Windows 10 operating system. D is the focus knob. This can go both ways, either direction, counterclockwise or clockwise, to get that focus that we discussed on the last slide there. E is the counting chamber, which is this piece right here. It is Corning's counting chamber. It is gridless, and it does come with the unit. Now, we can go ahead and use any regular hemocytometer that is up to a glass thickness of 0.1 millimeters. Also, we can use disposable slides on this as well, depending on what your application is. Under the counting chamber is the optical window. That's where the camera is, the 5 MP CMOS camera. So that's where you're going to get your high resolution image. And again, if you do have any questions on the cell counter, just throw them in the chat and we will get to them at the end of the presentation here. All right. So this gets us into the brief history. So the Corning cell counter launched and hit the market April 2018. So when it was launched, it had very basic functionality compared to what it is today. And it was viewed as, a disruptive technology. A lot of people loved what it was when it first came out. And, that's the power of the cloud, is that we have this ability to keep enhancing it over time to make it that much better than the last version. And here in 2018, it was on the market for 18 months. It did end up getting the Select Science new Life Science Product of the Year. So that was a great achievement for the product there. So now we'll get into the continuous upgrades, which is a big benefit of this part of the cloud. Cell counter. So we continue to have software enhancements that, really adapts to what the market needs. For example, back in probably 2019, the market need, all we heard was, we need to count PBMCs. And we kept hearing it, so we tallied it up. And we couldn't count PBMCs initially because the software was limited to 10 to 70 micron cell size. Now with a few software and algorithm updates, we're now able to count 4 to 70 micron mammalian cells. So right there, we're able to capture a cell line market that we weren't able to in the past. And then since launch, I listed some of the updates that we've seen. So we have the gating, histograms, trypan blue dilution calculator, and all of these updates are incorporated into the software now. So we're going to get into that once I go into the software portion of this webinar. And here's a good diagram of the Corning cell counter. So here's the unit itself. Here's your Windows 10 operating system, and there's the cloud. So basically, the way this works is that you focus your cells on top of the stage here, and you go into, the software. You hit count. The image is taken with the camera. It travels through a USB up into the cloud. It captures, all the data and kind of throws that back into the software for you to analyze your data. Really quick processing. We're counting basically millions of cells in the flash of a second. Let me see, tens of seconds. Let's see. All right, so here's the operating environment page. And basically, you're going to want to check off these 4 needs before you go into purchasing the unit. You need a Windows 10 PC or tablet, much like this one here. I think this is the Surface Pro. So it doesn't need to be the highest end model, but you do need a Windows 10. You need a high-speed internet and cloud access, which most of the universities here in the States do have. Here we go down. We need a USB 3 port, and the USB 3 port is necessary to kind of make that information travel in a quick manner. Once we go into USB 2, the information doesn't process as quickly, so that's a need of the USB 3 port there. And all the new Windows 10 do have that. And here, the cell size just needs to be 4 to 70 micron, and we are a go for the Corning cell counter. So now I threw the slide in to show you how easy it is to use coming out of the package. This is, what it's delivered in, a nice box with foam there for it to travel safely. And what you're going to want to do is go to download.cytosmart.com. Once you download that, this gives you the application on the desktop of the Windows 10 tablet. And then there is a license key process, which basically sets you up for that environment, much like if you sign up for an Apple account, which sets up your ID for that Apple device. So here we have, and then the USB 3 plug port, which we covered, and then you're ready to count. All right. So now we are going to go into the software portion of it. So this window here is the very first window you see when you go in and count. And Jeff is going to take us through that for his particular environment and the cells that he is using today to count over there in Bedford. So basically, you have a project here where you're going to name it. We're going into, which algorithm we want to use. And, as we keep updating the algorithm, most users want to keep using the algorithm that they have used. So as we update it, and if you're a new buyer, you're always going to want to use the newest version. However, if you're comfortable with an older version, feel free to use that version. So we have this listed here. Version 2 is the original. Version 3 is the new. And if there's ever any question on which one you should use, you can always contact us or hit this more info button. And this more info button is going to take you through what version of the software you should be using. And then you select here, if you have a sample dilution or if you have, the trypan blue dilution factor there. All right. And then what we're going to want to do now is hit start count. And this brings you into the window where you have to focus your cells And again, we want those live cells depicted as white, bright centers and dark edges. And the dark cells are going to be the, dark depicted cells that are stained with the trypan blue. All right. So once we have a good focus here, we're going to want to hit count. And I see Jeff has picked the version 3 of the algorithm. And that's one of the main differences of the algorithms, is that the old version of the algorithm, there was only one count, and then your results would pop up. Now, with version 3 of the software, we have this multi-count feature. So we can end up counting up to 8 times, and that is going to go ahead and average those results for you. All right. So now after we hit count, we get a good focus. It drops you into an analyze page. And, at first, you're kind of looking at this like, well, this is a lot of information. But we do break it down by tabs, and the different tabs have different functionalities here. So, every user is going to want to analyze their data differently. So we have an average multiple counts. See here, there's 8 images. And as I select the images, you're going to get different averages per that image. And, a lot of us would ask, why do we need different images? Say image 5 down here had a big clump of junk, basically, that you didn't want to count. You can go ahead and disregard that count and basically keep the 7 counts that you thought were good. You can go over here and add notes to the test. And everything that you do count is stored on cloud.cytosmart.com. And this is going to bring us over to the cloud portion. Another benefit of the cloud-based cell counter. And all of your results are saved here. You just need to sign in. And this is an unlimited storage cloud-based portal that our results are stored in and organized in. So this is the overview tab, where you'll see your gating functionality here, which we have the right to adjust. And then over here on the right side, this is where all of the meat of the data is, where we're going to have our total count, our dead count, and the live count. It'll tell you your cell size over here, and so forth. And then under the image with the green and red dots, the green dots are the live cells that the algorithm picked up, and the red cells are the dead ones there. Down here, we have the option to download the raw image, which would be no colors, just the cells that you focused. And then the processed image would be this one here with the green and red cells there. All right, the next slide here is going to show us the cell size tab. And on the cell size tab, we have a histogram. And you see here, we selected 4 pictures. So this histogram is averaging the 4 counts here. And then also we have the gating function. So this histogram also is only accounting for cells between 4 and 10 micron. So before taking the screenshot, we ended up moving these bars to show you that the results will change as you alter these gating functions here. All right. So lastly, on this page, we have a dilution calculator, which was just enhanced on the last algorithm update. And there's different functionalities here. So this is going to tell you how much cell solution you need to move on through your workflow. And Jeff will give us a live example of that in the coming minutes here. Okay, so now we have the analyzed data continued, and we're switching over to the concentration tab. Now, the concentration tab was also just added, and for the most part, this page is going to be really beneficial if you have kind of a higher dead count here, because those red bars are really going to show to say, hey, you only have 30%, you have 30% of your cell culture as dead, and you probably need to go ahead and recreate your cell suspension there. And then we have this AutoGate function, and the AutoGate function is used, generated by the algorithm to give the optimal gating of your cells there. And we have the export functions up here above the data, where we have a PDF report or for further options of images. All right. Now we can go into the live count. So what I'm going to do is pass this off to Jeff over in Bedford, and we do have a MIPS count. So this image here shows that Jeff is operating at a little under 12 MIPS, which is the internet speed he's working at over there in Bedford today. Our data that we collect is strongly suggested to have a MIPS over, in the 50 range if you're going to want to get a good count there at a quick speed. All right, so without further ado, I'll pass this over to Jeff.
All right. All right, thanks, Alex. So I'll be counting some MDA MB231s today. Again, as Alex showed, this is the start cell count screen. So we'll just start here. So I'll establish a good focus. Again, Alex mentioned there is a small learning curve. The more you use the instrument, the easier it becomes to use. It's a very small learning curve. So you just need to properly focus. So we'll say, that looks pretty good. So we'll hit count. And I'll just do a single count right here. Again, as Alex mentioned, there were things like VPNs and firewalls can actually slow down your internet speed. Our baseline speed has been shown to count in as little as 3 seconds if you have 72 MIPS. So again, 3 seconds is pretty fast. What we're getting here is actually not so bad either. Again, so what happens is your images go up to the cloud, they get counted, they get stored in the cloud, then they get sent back to you. So here is our count, and this is a count of 1. I'll show multi-count results in a minute, so we can take a look at it. So we can look at a histogram here too. So I can adjust that by pulling on these little handles here. It's 100% viability. I have some with some dead cells that I can show you too. So again, let's say that I'm satisfied with gating right here, and then I want to say I need, let's say, 10 mils at 1 × 10⁵. It tells me mix 0.382 mils of my cell suspension with 9.6 mils of buffer. I can save this as a note. So you can see this note right here. I can also put another note, for example, say, these are MDA MB231s, and then I can save that. And that's saved, and then you can look at that later in your experiment. This says who did it, when it was done, did you use trypan blue? The algorithm is optimized for trypan blue. You do not need to use it. It is recommended because the algorithm is so optimized, but it will count just as fine without. So again, that's for a count. So now I'm going to stop sharing, and I'm going to show you how the cloud application works. All right, so this is the count that I did earlier in preparation for this. And so, for example, this was a multi-count, so I did 4 counts. So I'm going to select them all. I could take a look at the images as well. For example, that's 1, that's 2, that's the 3rd one, that's another one. So actually, let's back up 1 step and find something else. So for example, let's say that you see this little snaky guy here, and you say, I really don't want that to be counted, because it again, sometimes the algorithm does see things that are not there. So we can just say, well, it's some debris in the sample. Nothing is perfect. So we can say, I'm not going to count that one. Now it's been excluded. It's gone from my counts. So other things you can do too, this actually has live gating. So you can actually, you can see you've got error bars here. You can actually look at your counts. And then, for example, this one here, let's say I don't trust this count right here. I can actually gate down until it goes away. So I can say, well, okay, 24, that's probably not, these probably are not cells that I'm interested in counting anyway. You can actually verify that with your population. You may wish to kind of cut the tail off there, and then you'll see exactly what the results of the live gating were. So again, that's multi-count, that's live gating, and you can also exclude. And so I showed the dilution calculator as well. So other things that are important, you can actually export your images. You can actually export your data through Excel. And actually, Alex mentioned there's a PDF report which gives you a nice summary. It'll show you the main picture for each of these, and it will also show you the results, the counts of each of them. And if they're excluded, then that will be excluded from the data. So excluding is essentially analogous to if you're doing flow cytometry and you set a threshold, you bin something out. If you exclude it, it's gone from the report. You can still find it here, and then you can say, well, I want to put that back, and then it goes back into the bin. So I'll show you another count actually. So let me stop sharing for a sec. So we'll start another cell count. So again, if you use trypan blue, the final dilution has to be 1-to-1 in trypan blue. If you have a very dense cell suspension, then you can say yes, here, and then you can say, well, I'm going to do another, for example, like 1+4 dilution. So then my whole dilution factor is 10. So the algorithm here, this is something Alex mentioned earlier, talks about the new counting range, and it shows the main differences between the algorithms. So, but again, this is just trypan blue and no sample dilution. Alex mentioned that it can use gridded hemocytometers. It is not good with the bright line hemocytometers. Those bright lines tend to confuse the algorithm a little bit. But if you have a dark field hemocytometer, that works great. If you have a relatively new, non-bright field hemocytometer, that works great. If you have an old beat up one, that's got all kinds of chips and stuff like that, that's particularly not good. Again, the good part is a fresh counting chamber with no lines comes with it. So it's actually fantastic. And it's a very high quality slide that comes with it. So we'll do another count here.
Jeff, did you want to go over the sample volume that you throw in the chamber?
Sure. As with all hemocytometers that you're using a Neubauer, so it's a 10 microliters, and that's to make the math work with the 0.1 millimeter depth. Again, disposable slides do work, as Alex mentioned, and you can use our slides. So again, if you have, for example, some disposable slides hanging out, and you say, oh, I might be reluctant to purchase because I can't use them. The majority of the ones that are out there we can handle. You can always contact us for support if you want to determine if yours work. For example, like the Cyto chip, that works fine. All right, and again, so if you look down in the lower left quadrant, you can see there is some cells that are in a cluster, and this declustered them very well. That was one of our recent improvements. And again, we can gate. You can also so let me show you back in the cloud now. So we can also turn off our lives and deads. So if you need to look, that's particularly useful when you have a higher percentage of dead cells. So I will send it back to Alex now.
Great. Thank you, Jeff.
Thank you.
Yep. And thank you everyone for staying on for the demonstration there. That was well appreciated by Jeff Partridge over in Bedford. So yeah, our cell counter, we're really helping people move from manual counting over to the automated fashion. And really what we're doing is helping clients save time. So we do have a special offer for today's attendees. With the purchase of our cell counter through Thomas Scientific, you will get a free Pyrex beaker mug, which is also great to use. I use it every day walking around the office there in Tewksbury. So now we'll open up for questions, and I did throw the specifications here just so we can take a second look at them and make sure your environments are correct for the unit. Sure. So I'll pass it over to the moderator to collect any questions, and Jeff and I will answer them for you here today.
Thank you, Alex and Jeff. That was fantastic. I really enjoyed the live demo. I would love to see one actually in person, so I might have to come up to Bedford sometime soon.
Well, we'll be glad to have you.
Are there any questions out there for Alex and Jeff? If you do, please write them and type them in the chat box, and we will get them answered for you.
One common question that we do get, Alex touched on some of it. There are no license fees or costs to run this web, the cloud application. There are, similar type of devices that web licenses are required. There's no fees or anything like that. It's unlimited storage. That's also at no cost, and there's no user limit. So if you buy one for your lab, multiple people in your group can set that up. So they can each get their own account with the one device. Again, remember though that the device requires an active internet connection with the Windows 10 computer.
Great, thank you, Jeff. I'm sure that answered some questions. We have a question in there.
Yep.
Where are the cell counters manufactured? Are they manufactured in the US?
I do see the question on the manufacturing location. This comes from our partner over in the Netherlands. So that's where it is manufactured. And our Corning reps do a great job of handing out the software, the hardware to the clients there.
Thank you. Are there any other questions for Jeff and Alex? So you can find this, if you can see at the top, you can order now. That'll take you right to the Thomas Scientific website. Or you can visit after this webinar. There's another question.
I'll take that one. So can pour slide quality give you false results? Definitely. Pour slide quality or one of those bright line hemocytometers, that's the silvered surface that was invented to make it easier for us humans to do cell counting using a microscope. That reflection can sometimes just confuse the algorithm a little bit. Again, if you have an old beat up hemocytometer, probably not going to be that great account. I've seen that during the development phase of this product, but we give you a brand new no line one, and that works fine. Brand new ones with the dark lines also work fantastic. We did a lot of validation on that. So there's a couple application notes that I published. They're available on our website. Counting of murine CAR T cells, and then counting of PBMCs. In both of those instances, I used a gridded hemocytometer to verify that the counts, using manual counting versus the Corning cell counter, had no statistical differences between either the counts or the viabilities.
Yep. Thank you, Jeff, for the answer there. And thank you, Oscar, for the questions. Looks like we have another one coming in here. Looks like it says, what are the terms of your demo program? So if anyone does need a demo, we have about 80 or so North America reps who all have a demo unit. So if you do need one on site to test your environment to make sure the unit works for your environment, we can go ahead and set up a demo. And that form to fill out is also on our website, which will get you going there to get that demo rolling.
Thanks, Alex. And if you have any questions regarding this, you can always reach out to your Thomas Scientific rep, and they will work with you and work with Corning to get your questions answered. And if you want a demo, you can also reach out to your rep, and they will coordinate with Corning for you and get that to you. If there are no other questions, I believe that's a wrap.
So Diane, it is a huge time saver. When we were doing some of our early work on it, again, if you've done the clicker and the eyeballs and and your own head looking at it, again, I'm a purist. I'll count the 4 big squares and then the one in the middle on both sides, so a total of 10 fields. That can be 3 minutes, 4 minutes, whereas with a good internet speed, you could count the similar amount of area in 30 seconds perhaps. It's also good for standardization. Once you train the people in your group, then everyone should get the same counts.
Yep. Thank you, Jeff, for answering that. Definitely mitigates the unreproducibility of user to user there.
All right. Thank you all for your time. Thank you, Corning, for doing this presentation and this training. It was very helpful for me. And I learned something new today, which is always a good thing. If you have any questions, please reach out to your Thomas Scientific rep. And have a good day, everyone.
Thank you, Rebecca. Much appreciated for helping set up this live webinar here.
Absolutely. Thank you.